I thought you would know that one. And then birds or bees?
They both, in some contexts, they mean the same, right? The birds and the bees, but I'll go with bees.
All right, and that's a perfect transition to our conversation tonight, the future of bees. So before we get into the deeper questions, maybe just a few words about yourself and the company that you're currently CEO and co-founder of.
I'm Sar from Beewise. Thank you, everybody, for being here. Appreciate you guys taking time off your busy schedules. Um, and Beewise is a company that made its mission and our raison d'etre, right? Our reason for existing in saving the bees. There's a lot of faces to that. We'll talk about the commercial side and all that, but essentially we are here to save the bees, and we're throwing everything at it, right? Existing modern technologies like artificial intelligence, neural networks, precision robotics, computer vision, anything we can find that is accessible and available to actually apply it towards the benefit of the bees, to allow the bees not only to survive, but to thrive, which is kind of something that most people don't even think about. We're all talking about survival of the bees. We're thinking about, okay, using modern technology, we can actually allow bees to thrive in nature.
Amazing. So at least for me, and I think when most people think about bees, they think about honey. um, what else are they missing out on? How are bees used today in other ways?
So again, probably some of you already know this, but I'll just repeat it because it's so important and strategic. About 75% of all the fruit, vegetables, seeds, and nuts that we consume on this planet is pollinated by bees. And again, 8 billion people, 75% of the fruits and vegetables that we eat is pollinated by bees. And we all know today, I mean, we can live off of corn and rice, but we all know that a healthy diet means, longevity and a healthy, healthy and well-being. And so bees are the ones who actually do that part of the pollination. And so they're strategic to our global food supply. It's not just about the honey. Remember that every time a bee goes out to the field and pollinates a flower, they bring back nectar and pollen into the hive, and that's how they produce honey, which is their carbs. And so the honey is nice, and honey is actually pretty ubiquitous today. Most people think about honey as, the honey jars or Winnie the Pooh, but honey is mostly utilized today in Honey Nut Cheerios and other products like honey Dijon mustard and so on, and even cosmetics and healthy foods like propolis and the things we take for a sore throat. These are all products of the bee, but it all starts from pollination. And I always like to think about the bees as the infrastructure of farming. I'll just add another word about that. You
Sure.
can have an amazing almond grove with amazing soil and good grains, motivated labor, perfect weather, and even like great netafim irrigation. If you don't bring in the bees for pollination in February, right now this month, you're probably not going to get much almond. And so it's kind of a limiting factor, right? You need many things beside the bees to produce an almond, but if you don't have the bees, you're not going to get your almonds. And so this is why we see them as the infrastructure of farming, uh, um, and very strategic to our global food supply.
So let's take a step back before we take a step forward. Um, Obviously, bees naturally in nature only have a certain amount of capacity to produce these almonds and other crops and vegetables. How did this creature become integrated into this global food chain that we now take for granted in many places?
So there's a very strong symbiosis between the bees and nature, or the flowers actually. Nature has worked very hard for the last, somewhere between 200 and 100 million years to actually create a perfect match between the bees and the flowers. Things like, we don't always necessarily think about them, but the length of the tongue of the bee is perfect for the depth of the flower and where the nectar is, which is how they collect the nectar with their tongue. So nature has worked really hard for 100 million years to create this perfect match for flowers that need pollination. They need their male organs, their male pollen, to kind of move to the female pollen. And nature has created the bee to do exactly that. And so it used to be the case where bees were wild and there were many in nature, and they would pollinate enough fruit and nuts and seeds and vegetables for humanity. But we kind of we outpaced nature, and now there's almost 8 billion of us. And so we kind of commercialized and industrial the bees, or the pollination part of the bees, to kind of accommodate our global food supply.
And what does that look like? I mean, practically speaking, how do we take this creature in nature and then, almost artificially insert it into the farm, sort of ecosystem?
What happened is, in about mid 1800s, a gentleman by the name of Longstreth, he invented the modern beehive, right? The white wooden box that's now almost 170 years old.
Yeah.
And in that box, he found a mechanism that lures the bees and creates a good enough environment for them to live and thrive. And so these frames, the honeycombs that we see in hives, this is what he invented. And so the bees come there and they live there and they grow their colony and they produce honey in there. And they also go out and do what they do in the field, which is pollination, in order to produce the honey that they need. Remember, just one interesting anecdote that not everybody knows is that the bees' honey is the food they produce for themselves during the summer, so they can have it during winter when there's no forage. Right? When there's a lot of forage out there, they produce honey and they store it so that they have food during the winter. Now, honey has no shelf life, so you can actually store it for a very long time. And so this is their trick to survive harsh winters when there's not enough forage out there. And so these hives, these wooden boxes, are being used today by beekeepers, especially by commercial beekeepers. They move them around for pollination purposes. So in February, they come in and they pollinate the almond. And then in March, they go, northwards towards, Oregon and Washington to pollinate the apple. And then they go inland to pollinate berries, and so on and so forth. So beekeeping today is a migratory business. It's a migratory profession, so to speak, so that they can move their hives around for pollination purposes.
How do they get moved around? How do you move around bees?
So they're in hives, and think about commercial beekeepers as those who have thousands of beehives, and they just load them on trucks. It's kind of weird when you think about it, right? Think about 75% of the global food supply, right? The fruits and vegetables that we consume everywhere in the world, right? China is the biggest consumer of tomatoes and cucumbers. It's not like just the US or Europe, it's ubiquitous today. People in white protective gear move wooden boxes from one field to the other. This is how the infrastructure of farming works today. It's kind of mind-boggling when you think about it. And what they do is they actually load them on trucks, right? So you see 18-wheelers, you see those big semis,
yeah,
and they can hold up to 400, or a little bit over 400 hives, and they move around. And when you have to move 2 million hives throughout the year across the nation, think about 2 million hives divided on 400 hive loads. It's a lot of thousands of trucks moving around the entire nation, entire country, just to move those hives from one orchard or from one crop to the other throughout the year.
Yeah, that's crazy. Are you a bee?
I could be a bee, but but no, right now
You're a
I'm a
human
human
still.
being.
You're
Yeah.
spending so much time around the bees, sometimes you just become that at a certain point, but it's good to know you're still wearing the human hat. So what happened in the recent past that brought bee health to our collective consciousness? Was there some sort of catalyst, because they've been very prominent in the news cycle in the last several years? What happened?
If I had to sum it in one sentence, or even actually two words, I would say we happened.
Hmm.
So nature has worked really hard to kind of create this perfect match, this love affair between flowers and bees, and everything worked well until we came along. And in a mere 50 years, think about over 100 million years, this mechanism has been working well. And we humans, in 50 years, were able to, like we do with many other things on this planet, we disrupted it, and we broke it down. And what we did are some things that I'll kind of talk about now in 30 seconds, and I'll kind of show you how we break stuff. Sometimes it's good, most of the time it isn't. So first of all, climate change, right? We see the effects of climate change, of the industrialization and modernization, and that affects the bees. It affects them tremendously, right? They grew up over millions of years in a certain environment, and now the environment is changing, and it's changing fast.
Mm-hmm.
And they can't adapt. It's too fast for natural selection to help them adapt to the changes we bring in less than a century. The second thing is pests, right? There's certain pests that used to exist in certain regions of the world with certain type of bees that could cope with these pests, right? Like the varroa. Look it up after this Zoom call. And so what we did is, we made the world very small, and we moved things around between countries. So we moved the varroa from one area of the world to the rest of the world, and now the varroa is ubiquitous and prominent. And the varroa is a pest that it doesn't allow the bee to filter certain poisons, right? And so the bee, essentially think of the bee as not having an immune system because of this little pest. It sits on the bee and it sucks its immune system out, literally punches a hole in the bee. And so these pests, we kind of brought them along, right? Pesticides. The pesticides we use in the field to keep our trees healthy and our crops healthy are killing our bees.
Mm-hmm.
And so if I bring in bees to my crop, right, the bees don't know where the limits of my crop are. They just go all around for 2-3 miles. And so they go to my neighbor, which happens to put pesticides that same day in his fields or in her fields.
Yeah.
And the bees die, colonies collapse. And so there's for the bees, unfortunately, it's the perfect storm. There's a variety of reasons why the bees or the colonies are collapsing, and it's all happening simultaneously. And all these stressors are really, that's why we're seeing such tremendous bee declines. And I would say 100%, but let's just be cautious. 95% of that is because of us humans.
Mm-hmm. Mm-hmm. Maybe just let's dive in a little bit deeper on those elements that you've outlined. So, is there anything that we can do in terms of climate change that would have a material impact on the bee health? Is there anything we can do in terms of reducing our pesticide usage that you think is realistic, and we can actually turn back sort of that threat? And obviously the varroa mite is here. Is there any way we can give bees immunity against this creature that's constantly on the hunt for bee populations?
So there might be ways. The declining bee populations is a problem that we've been talking about. Humans for about 40-50 years. We see those declines happening for the last half century. So over $100 billion has been spent over the last 50 years to save the bees by private institutions, public institutions, universities, private companies. Many people are trying to save the bee, and for good reason.
Yeah.
And so there's some crazy ideas, like you say, can we change the bee's DNA to cope better with certain modern stressors? Can we change climate change or undo climate change? Can we stop pesticides from being used in the fields? So there's a lot of things we can do. They haven't been super successful in the last 50 years. And so when we looked at the problem from our standpoint, Beewise, what we realized is it's going to be very expensive and will require many, many years to get rid of those stressors that we see, that are basically affecting the bee populations.
Mhm.
And so what we did is we kind of took a different approach, and we said, okay, instead of changing the human nature or the bee's DNA, why don't we give bees a fighting chance with modern technology that is relatively cheap, right? Off the shelf existing technologies, neural networks that are today pretty common and accessible, precision robotics, relatively, again, accessible and cheap, and put all that into work for the benefit of the bee.
Yeah, so it seems like a pretty elegant approach. Another, question on that front is just out of curiosity. What about like cell phone towers and all of the signal in the spectrum that's being transmitted? Does this confuse bees and cause them to sort of be flying in circles as opposed to being on making a beeline for the flowers?
Yeah, there is research that shows that, but then again, there's research that shows the opposite, and for every paper you'll find, there's two others that say something different. So
Mhm.
we don't know too much about it, and I can't say I know about it enough, but I would say in general, just a general thought that when you have a weak bee population, many things that shouldn't affect the bees affect them. It's like us
Mhm.
humans, when you're sick, every little thing can disorient you or can take you down, essentially. And
Yeah.
so, you mentioned the varroa mite. The varroa mite is that pest that essentially eats the bee's immune system. So bees today, almost 100% of the bees in the world, let's just take, again, to be on the safe side, 80% of the bees today have the varroa mite. They are born without the immune system. The varroa mite affects the bees before they're born. It
Oh,
eats their
wow.
immune system. When the bees hatch, they hatch
They're
with a
already
very
weak.
weak immune system. They're
Is that
weak.
because
And
is that
so
because of their
now,
mother was affected by the mite, or how does that
no,
happen?
the mite actually goes in and it latches onto the bee when the bee is still a brood, when it's still in its like
Infancy?
well, yeah, before it hatches, right?
Yeah.
The bees go through several stages before it hatches, and the varroa mite goes into the actual honeycomb, where the combs. It's not honeycombs. There's no honey there. There's brood, and it actually affects the bee. And when the bee hatches, the bee is already weak with almost no immune system, and so many things affect it. You don't need a lot of pesticides to take down the bees today. Whereas if the bee was strong and the colony was strong, they might be able to survive
Mm.
a pesticide infected field and still just come out of it strong.
And there's a lot of different species of bee. So is that, consistent across all bee species, that phenomenon that's happening? Or are there certain bee types that are, just naturally stronger or naturally more, resistant to these threats?
Yeah, so there's, when you say many, species of bees, there are, thousands, and some say even tens of thousands of species of bees, and some are naturally immune to the varroa, right? The
Yeah.
varroa, this specific mite, has been growing for the last millions of years with bees,
Right.
and colonies were able to adapt and cope, but not the common honeybee, right? The bee
Yeah.
that pollinates, that bee doesn't know how to cope with the varroa. So I would say there's bees that can cope with anything, right? Somewhere in
Right.
the world. But the most common bee that we see today are the honeybees that actually both pollinate and produce honey. And these bees are the ones who are declining now, and we can't really, they can't cope with these modern stressors.
And have we seen the impact of these bee populations declining on crop yields and prices of certain, vegetables like avocados, for example?
Yeah, look, I always like to kind of think about supply and demand as something that has a certain dynamic. So, flat screen TVs didn't used to be the norm. Back in the day, they were very expensive, and they were a very certain size, and you can only afford if you had a lot of money.
Right.
But as demand outpaced supply, the prices plummet, and kind of supply started to kind of close that gap, and prices go down, and that's a natural dynamic in any industry, almost any industry that's kind of commoditized, right?
Yeah.
When you look at avocados, for example, or even cucumber, which is a much more common vegetable, you don't see that trend. The prices fluctuate because there's a lot of uncertainties when you produce these crops. And so when you don't have visibility and projectability in terms of how well will pollination work, because guess what? You ordered 1,000 hives, but 30% died over the year and you got only 700. You're not going to get the levels of pollination you need to pollinate all the flowers. And if you don't pollinate all the flowers, naturally you'll get less fruit or vegetable. The crop, the yields will be lower. And so there's a direct correlation between how strong the pollination is and the crop that you get at the end. Now, if you don't have enough crop, you don't get enough. If you don't have enough, pollination, you don't get enough crop. If you don't get enough crop, the prices fluctuate. If the prices go up by 1% for cucumbers or tomato or even avocado, some populations still would have access to those vegetables, but there's some populations in the world that just a 1% increase in prices actually excludes them completely from those crops, from tomatoes and cucumbers. And unfortunately, those populations are usually the ones that are kind of more unfortunate and poorer. So this fluctuation in prices, to some extent due to pollination, actually affects the more unfortunate populations on this planet.
And so how do you guarantee pollination and make sure that you don't have to deal with these uncertainties around how many bees are going to be alive and how many bees are going to be available for a specific, grow or season?
You can't, right? Because you have declining colonies every year, we're losing somewhere between 20 to 40% of the colonies in certain areas. For example, in the US, every year 20 to 40% of the colonies collapse. This is sometimes referred to as colony collapse disorder, but in general, think about
people
the mortality rate of the
game.
colonies.
People are playing a drinking game on this fireside chat. Every time you say colony collapse disorder, they take a shot. So that's the first time you said it. Now we'll be listening for number 2 and number 3. Go on.
CCD. Well, if I know now, I'll say it much more. I mean, I want people to have fun on this
exactly.
evening. But the idea is that when you have something that is not within your control, it's not a controlled environment. You lose those populations. You really don't have a lot of projectability and a lot of visibility in terms of how much effective pollination you'll get next year. And that's a problem. And so when we get to our solution, we'll talk a little bit more about how we solve for this.
Now, just a question before we jump there. I remember we had a discussion earlier on about farmers who are trying to vertically integrate and actually bring beehives onto their farms, and then kind of guarantee pollination or have more control over that process. Has that experiment panned out for those growers, or has it been sort of a flop?
I would say that depends who you ask. If you ask them, they might say that it's a success, but I would say objectively, we don't see that enough, meaning that there's no commercial viability to that pattern. And that is also a lot to do with the declining colonies. What happens is when you lose a lot of your revenue generating asset, which is the bees, every year, you really have to be a very professional commercial beekeeper to try and kind of hedge that, right, or to control that. And so farmers are farmers, they're not beekeepers. Beekeepers are the ones who know how to grow bees. They're called
Right.
beekeepers, they keep bees.
Right.
And so some farmers have tried to integrate beekeeping into their business, into their enterprise in order to guarantee or at least have access to pollination. But most don't do it. And again, one of the reasons is the lack of technology. When it's all manual labor, right, that depends on people, specific people that know how to keep bees, the professional beekeepers. Then if you don't have access to those professional beekeepers, even if you wanted to grow bees, you couldn't.
Interesting. So, if we had more beekeepers and more people, working in these yards and working on the hives themselves, do you think we could do a better job of protecting the bees?
Yes. So the idea is that the professional beekeepers, they know how to treat bees. They know how to keep bees and how to grow bees. So if a commercial beekeeper would visit their hive, all of their hives, every single day, they would be able to treat their hives in a much more precise manner. So if they identified a disease or a pest, or if they knew there were pesticides around the hive, they could take action in real time, right on the spot, and save the bees. Right? If you see that your neighbor is applying pesticides, take the combs out. Right? Move the combs around, or if it's too cold, warm them up. If it's too hot, cool them down.
Right.
If you see a disease, apply a medicine, antibiotics or whatever you need to. But that's not really feasible at scale, right? Think about people that manage thousands of hives, and hives are scattered over vast regions. You can't really give your hives or your bees that precise real-time treatment when they need. Unfortunately, even if you have some monitoring systems around that monitor your hives and tell you when things are wrong, you still have to jump on a car, drive, treat your bees, and that's just, the labor is cost prohibitive, and that's why we see the declining numbers.
Right, and what's stopping the beekeepers from concentrating the hives all in one place and sort of, reducing that spread geographically?
Yeah, again, if you're a commercial beekeeper and you want to produce honey, you need a lot of forage. Or if you want to pollinate, you need to take your hives to the almond grove. And so there's an almond grove in California, and there's pollination in Washington, and there's honey producing forage in North Dakota. So you split your portfolio. So your hives are really scattered over very vast regions. Sometimes beekeepers have to drive 2, 3, 4, 5, 6 hours just to get to the hives themselves and treat them. And this is why the frequency of visits, the frequency of treatments of bees is usually once in every few weeks, 2, 3, 4, 5 weeks. And that's just not good enough. If you come in 3 weeks to this hive, if there was a disease during that time, if there was a pest, or if there were pesticides, you're going to find a collapsed colony, and it doesn't matter what you do.
And then isn't there also like a generational transition issue here?
It's funny that you say that. The UN has put, one of their top strategic goals or their threats is that the pollinators are disappearing, right? The bees are collapsing. The second biggest threat is that the beekeepers are disappearing. Yeah, I don't know many people that went to school and came out and said, "Oh, I'm going to be a beekeeper for the rest of my life." I mean, that usually it's kind of something more a family business, or that you kind of found yourself into. But we don't see an influx of beekeepers coming in to replace the older generation today.
Right. So we have colony collapse disorder and we have beekeeper collapse disorder.
Let's just call it beekeepers retiring, okay? I mean,
Okay, so I think the picture is clear. You know, there's a real issue, and there's not a clear way out using existing approaches. So maybe you can shed a little bit of light on, you know, the approach that you guys have developed, and you know, sort of what you've learned so far in building this new approach.
So what we did is we realized that a lot of these things are affecting the bees, and one of the limiting factors is the fact the bees are being kept. The beekeepers are keeping the bees in these wooden 150-year-old hives, right? 170-year-old hives. And when they drive over to their hives because they need to treat the hive or the colony, they have no clue what they're going to find. Again, they come and they take the whole factory with them, right? They might find a collapsed colony. They might find a hive that, or a colony that needs medicine or water. Maybe there's not enough forage. So they bring everything with them. They drive for many hours. They get to the bee yard. You cluster hives together. They're not one by one. They're usually about 20 to 40 together, clustered in a certain area that is called a bee yard. They get to the bee yard and then they open the hatch, so to speak. They look inside, and only then do they know what's going on in their hive. Until that point, they don't know. Think about running a business. You have 10,000 of these boxes. That's your revenue generating asset. And you, as the owner, you have no clue what's going on. You just know statistically during this time of year what you should expect. But realistically, it's not a data-driven business. It's a business that is driven on, you know, you get what you get and you don't throw a fit. And so the idea is that once we realized that, we realized first of all, there's not enough monitoring on those bees. There's not a mechanism to know and tell what's going on. And then when you do find what's wrong, there's no system in place to actually treat the bees. Now, look, I always like to give the example. I have a 4-year-old son, and if he has ear pain, you know, that same night, I put a few drops in his ear, and the pain goes away. Problem solved. 3 drops can solve you a lot of problems. But if you wait for a week and you don't treat him, you might have to give him antibiotics after a week. And if you don't treat him then, we might have to take him in for a procedure after 2 weeks. And so the idea of real-time treatment is critical to saving a colony. The same thing applies to bees in any biological model.
Yeah.
And so what we've developed is this device behind me that what it does, it contains 24 hives, 12 on both sides. And in the center, there's a robot that constantly monitors the bees in the hives. And that robot has a very powerful brain, so to speak, artificial intelligence that identifies exactly what the bees' needs are. There's 1 million bees in this device. In every one of these devices, about 1 million bees during the high time. And so the robot monitors, the artificial intelligence identifies what the needs are: food, water, too cold, too hot. There's a pest, there's pesticides, there's a disease. And then the robot itself treats the bees inside the hives, right? So it applies the treatment towards the hive. And the results are staggering because that real-time treatment, it's just the same as if a beekeeper would be there. We mimic a beekeeper. We did not invent anything around beekeeping. We apply the same beekeeping techniques, exactly the same beekeeping techniques that a beekeeper would do in the field. We just do it with a robot. And the bees, they don't mind if it's a human eye looking at them or a camera. They don't care if it's a human hand, you know, treating them, or a robotic hand. It doesn't matter to them as long as you treat them. And what we've seen, we have tens of these devices scattered in the fields. Some are operational for over 2 years. And we've seen a less than 10% colony collapse. It's actually less than 8%, 7.59% colony collapse consistently throughout a couple of years in these devices. And the only thing we do, again, this is a very nascent product, right? We're only 2.5 years old. This is a very, very new product. And still what we see is an incredibly decreased mortality rate or collapse rate of colonies just because of the sheer fact that we can treat bees, and it's all done remotely in the field. Nobody has to actually drive over there and apply treatment and rush the hives out when there's pesticides or get rid of varroa manually. It's all done inside this device completely autonomously by a robot.
It sounds too good to be true. So maybe it is. How do you even identify, what a mite looks like, inside of a dark metal box, and how do you, decide which hive to put spray on, and how does it not affect other hives? And kind of, I know it's a it's a black box, if you will, but maybe you can share a little bit of light on, how you've managed to overcome some of these problems initially.
Yeah, so there's a lot of problems that we had to overcome. There's a lot of learning, a lot of technology and IP in this device. Many, over a dozen of patents, actually 18 patents on these things. So the things you mentioned are the challenges we had to overcome. And not only that, the biggest challenge is how do you do it cost effectively, right?
Right.
Because you can solve any problem on this planet if you throw enough money at it, and you can make a very expensive device. But making a very cheap device that you can now scatter, around the globe instead of the old hives, that was the big challenge. And I'm happy to say that we were successful in making this a very cost-effective solution, right? Think of it as a solution. And yeah, we literally have eyes on hives. We see everything that is going on. And a neural network actually identifies all these things from varroa through brood, honey, pollen, eggs, varroa eggs. So we know when there's eggs in the hive and the queen is performing. We can see the queen, we can see swarm cells, and we can see superseder cells. We can see everything inside the hive. And when I say we, nobody's looking at it. It's an artificial intelligence that is looking at these things. It's marking everything that it finds, and it raises red flags when it needs to. And the red flags are not raised to the beekeeper. We're not interrupting the beekeeper. He might ask to be notified, but we don't need the beekeeper, because if we see a problem like a swarm cell or a superseder cell, the robot itself makes a decision on what needs to happen, because these are very simple rules. If you identify a swarming starting to happen, and we do it visually, just like a beekeeper would do. Remember that a beekeeper comes to the hives and they open the hatch and they look with their eyes. We do the same thing, right? Same techniques. Nothing has changed in beekeeping. And so if it's dark or not, that doesn't matter to the camera. The camera can see everything with amazing resolution. And the artificial intelligence, you train it to work, and after some training, it works pretty amazingly. And then there's another neural network, which is called a recurrent neural network, which is really reinforcement learning. It learns how the specific actions that it took affect the result, and by that it becomes smarter over time. And as our portfolio grows, that AI learns more and more and becomes essentially a better beekeeper.
Incredible. And I assume you've watched a lot of this footage just out of curiosity and for fun. How often do you find yourself dreaming about bees?
We all dream about bees. You know that, we're only 30 people strong in our company. And so, but every hire that we hire to our company, the criteria is, whether they get attached to our mission. You can be the most talented person in the world in your specific area, but if you don't get attached to what we do, to the fact that we're trying to save the bees, the first solution on the planet to actually save the bees at scale, if you don't get attached to that, you're not going to be part of the Beewise team, because we all have to be aligned. When we come to the office, we come not only to another day at work, we come to save the bees every single day, over and over again. And so, yeah, we dream about bees during the day and during the night, all the time, seriously.
Amazing. Maybe some of our audience members will also dream of bees tonight after this fireside chat. Now, when you look ahead 5 years, what does the future of commercial beekeeping look like? And it seems almost inevitable if this is priced, in a cost-effective way, that if you look really far out, the wooden box will actually be just a relic of the past. No one would opt for that technology once this thing is, accessible and affordable, right?
Yeah, so that's my hope. I want to stay humble and realistic. The idea is this, though. What keeps me going is the fact that, we all tend to think, when we see those wooden hives in the field, we tend to think it's a very romantic thing. And some people make the mistake of thinking that's the natural habitat of bees. It's not the natural habitat of bees. Bees build hives in trees, in the
Right,
ground, on plants, right? We humans, a gentleman by the name of Longstrauth invented that hive, and
right.
since then it became the standard, right? So there's a certain critical mass of hives that were sold for
Yeah,
that specific wooden box to become the standard. And by the way, that white box, if you really think about it, it's a black box. You have no idea what's going on inside until you open it up. It's just colored in white.
yeah,
But that box became the standard, and so today, that box doesn't work anymore. With the modern stressors that are happening around the globe, that box is killing our bees.
yeah,
And so our box isn't. Our box is keeping the bees alive. And again, like I said, we see a less than 8% colony collapse. We can even lower it. I have high confidence we can lower that once we start optimizing for that. We're not even optimizing for it yet. This is a pretty nascent product, like I said. But I want to get to that critical mass, to that threshold from which this becomes the new standard, right? When you see enough of your competitors in the fields use this device and make data-driven decisions, be able to see on a computer monitor the internals of your hive 24/7, up to date, see the actions the robot took to save your colonies, see what could have happened if the robot didn't take that action, what actually happened now. When you realize that, uh, I'm hoping that there will be a network effect where people will start utilizing this technology. And yeah, hopefully this will become the new standard over the course of the next few years.
amazing. I'm going to open it up for questions to the audience. If anyone has, something that they're curious about, we have the man, the myth, and the legend on the line for another few minutes. So feel free to submit your questions via the Q&A. In the meantime, yeah.
Don't be shy. We could do puns all night long. Yeah,
we can. Let's see. We got one question coming through. It was more of a thank you, not a specific question, but Anita Zager appreciates what you are doing for the bees and the whole planet, and appreciates the questions and the answers.
I just want to answer to that real quick. I know it's not a question, but Anita, I want you to realize, and anybody else that is aware of what we're doing, we haven't done anything yet, right? The idea that you invent a technology is not the solution. It's just the potential to save the bees. Now starts the really hard work. How do you distribute this? How do you make it work, at scale? How do you cope with the problems that we haven't identified yet? How do you cope with newer problems that the bees will face? So we have a very long way ahead of us. I'm very confident in the technology that we've created, very much so, and I'm lucky enough to have met people who kind of allow us to do this and kind of finance us along this journey. But really, just to kind of really keep things in perspective, we have not done anything yet. The real journey begins now. We actually have, like I said, over 40 of these devices scattered in the fields. By the end of this year, we plan to have a few hundreds, mostly in the US, East Coast, West Coast, Midland. And next year, we're planning on having almost, thousands of these devices, and the year after, tens of thousands. So we're very adamant and very stubborn at solving the bee problem. We're all coming to work very mission driven to save the bees. And we're a commercial entity, meaning we're not doing it, we're not a not-for-profit that can evaporate tomorrow. We really are very focused on making this work. And time will tell how successful we'll be.
Thank you. And then we have another one from John in the audience, basically wondering about robotic bees as opposed to real bees. Is that potentially a more accessible or sustainable solution? Not have to keep growing bees, but just to have tiny little robots flying around carrying pollen.
And actually, there are companies who are doing this, who are working on such solutions, and I appreciate any technology that would save the bee eventually. And I always see that when you deal with such a big problem, any competition could be co-opetition, and you can cooperate with your competitors because we all have a common goal. That's very important to me, and I work hard in trying to make that happen. But I would say, there's two general philosophies when you think about bees. One is, the bees will go away. We're going to lose them in the next 10, 20 years. And so we need an alternative, hence robotic bees or robotic pollination, or there's a lot of good ideas around that whole paradigm of we'll lose our bees. And then there's companies like us and other companies in the world that are doing a good job. Some are Israeli in the US that are doing a fantastic job at thinking, okay, we're going to try and save the bees. We actually believe the bees will stay. They're here to stay. We're going to give them a fighting chance. And so how do we actually enable them, right? Instead of replace them. Replacing bees is just, it's, I hate to think even about that option, but when you think about it really kind of from a professional standpoint, it's a very expensive thing. If you want to have robotic bees, I mean, just to give you guys a perspective or some context, in a wooden box, there could be up to 100,000 bees, 50 to 100,000 bees in that single wooden box. And so think about our device. We have 24, the equivalent of 24 hives, which is about 1 million bees. And so there are 100 million hives in the world. Multiply 100 million times 50,000, that's a lot of bees. And they're relatively cheap to maintain and to create. It's nature, right? Now, if you want to have the equivalent of these bees using robotic bees, it feels to me like it's cost prohibitive, but many people say that about our solution. Many people think our solution is cost prohibitive too, and we proved beyond all doubt that it's not. And so I might be mistaken about robotic bees, and maybe that's one of the solutions. And there's always the hybrid model, right? Use bees and use robotic bees at the same time to complement each other. Definitely a solution.
Cool. Okay, we have a few other questions. One is, are you considering Shark Tank?
I'm not. I'm too scared for that.
Yeah, Cuban missed this one though. He should have taken a stab at the seed. And then we have another question. How do you envision this working within climate change? But I'm not sure I really understand the question. So
that's a good question, actually. Climate change is a moving target, right? It's not something that you solve for now because we keep ruining that over and over again. It gets worse, and suddenly we find wildfires. It's a big problem for bees today. It didn't used to be. Floods is an issue for bees. It didn't used to be.
Right.
So how do you cope with that? Again, I actually think you cope with technology, right? Now here's what I'm going to say. I'm going to answer any question you guys have around features or how do we cope or what do we do. I want you to think about it this way, right? When you have a platform like that has power, connectivity, and artificial intelligence, you have a platform. You can do anything. You can add software, you can add hardware, you can solve for any problem that arises in the future, long-term and short-term. That wooden box, that 170-year-old wooden box, is not a platform. You can't do almost anything in it. You can put some sensors in it, you can weigh it. You can't really manipulate it as much. And so
Right.
what's important is the transition to this new beehive. When you move to this new hive, which is a platform, then you can really start fantasizing how to cope with big issues like climate change. I'll give you guys an example. Pesticides, big problem, right? People put pesticides over huge areas. How do we cope with them? This device, you see those openings here? All these openings are where the bees come in and out. These are the entrances of the bees.
Mm-hmm.
If we sense pesticides in the field, we have small sensors, they're very cheap. We put them all around the device. If we sense pesticides or any harmful substances, we shut down the device. It just locks down. It closes all these hatches. And so the bees are in the field. I mean, they're gone. They're dead. There's nothing we can do to help them. They've already tasted the harmful substances, right?
Mm-hmm.
They bathed in them. But the bees inside, the colonies, the queen, what keeps the colony alive, you want to save that so you don't have the colony collapse. When bees come into the hives with harmful substances, they actually they affect the entire hive, the entire colony. So if we prevent them from coming in with those substances, we can actually save the colony. So you close the whole device for a day, for a couple of days. Then you open it back up, and you saved 24 colonies, or maybe 2,400 colonies.
Yeah.
With a very, very simple mechanism, just shutting down a mechanical, silly mechanism, right? And so this is what I mean when I talk about a platform. You can do amazing things in a very cheap, cost-effective way that have tremendous impact on bee populations.
Yeah, and I'm excited to see what the future holds for the bees now that we have the bee home. And I want to thank. Wait, let's see. Okay, yeah, I want to thank all of our attendees for again making time to learn a little bit more about this incredibly unique creature that was recently declared the most important living being on Earth. And I really appreciate your time as well, Sar. Thank you so much for joining me for this lively conversation.
Thank you for having me, and thank you guys for your comments. That's actually a good idea about the Shark Tank, just the exposure. But thank you, everybody. And I just want to leave you guys with one thought, if I may, right? Like always, people say one last sentence. Spread the word. Spread the word, because we want to give bees a fighting chance. We want to change the course of history. We want to have a point in history where suddenly, the course of things change for the better for the bees and for humans too, right? We're all dependent on the bees' pollination. And so we're hoping, I'm a technologist. I used to be a software guy, so I believe in technology, and I believe technology can solve almost for everything. And this is how I apply myself to saving this planet, one bee at a time. And so if you see these devices in the field, take photos, upload them, send them to us, hashtag them, and hopefully you'll see more and more of them and more bees buzzing around.
And maybe
Thank you
even
for
a
having
bee,
me.
maybe even a bee wrap if we're lucky.
I'm looking forward to that.
Good afternoon, good evening, good night to everyone, and looking forward to the next chat. Toda. Thank you.
Have a good night. Bye-bye.
Bye.